So fundamental theorem of arithmetic says any composite number can be expressed as the product of their prime numbers. The product of 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3 etc. will give the number of positive divisors of the given number. What is the value of 2 to the power of 11? Since you know the value of 2 to the power of 10, 2 power 10 is 1024. 2 to the power of 11 can be written as 2 to the power of 10 into 2 to the power of 1. What is 2 to the power of n? 1024 into 2. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the temple of excellence. Today in this session I am going to take the first chapter in first PUC basic mathematics. The first chapter is number theory. Number theory is the first chapter. Now, before going to the exact chapter, let us know regarding the weightage for this chapter. So, the weightage for this chapter is 10 marks. So, totally you will get 10 marks from this chapter, and so it will carry only 1 mark question, 2 mark question as well as a 3 marker question. No 4, 5 marks essay type question. So, here, so the short answer questions, very short answer question is 1 mark question. You will get 1 question for 1 mark. And short answer questions, that is for 2 marks. So you will have 3 questions. So totally 2 marks questions, 3 questions, you will get 6 marks from that. And 1 long answer question, that is 1 question for 3 marks. So 6 plus 3, 9 plus 1 is 10. Totally the weightage for this chapter is 10 marks. So 1 mark 1 question, 2 marks 3 question, and 1 mark that is long answer 3 marks 1 question. So 3 plus 6 plus 1, totally 9 marks you will get from this chapter. Okay, so very easiest chapter. So this is nothing but the revision of what you have studied in your previous classes like 8th, 9th and 10th standard. So in this number theory, now in this chapter what we are going to study, now here in this session I am going to discuss regarding introduction to the numbers and fundamental theorem of arithmetic as well as the problems based on this. Now, introduction to the number theory and fundamental theorem of arithmetic as well as problems based on this. Now, let us come to this. In this chapter, we will study about the numbers and their properties and the application. So, in this chapter, today I am going to discuss regarding the very important concept about the numbers and the properties of numbers. So, in this chapter, we are going to study regarding the numbers and the properties of their numbers and the application of these numbers. Then let us come to the first concept. Let us know regarding the natural number. You might have been studied the set of all counting numbers forms a natural number. All counting numbers 1, 2, 3, 4, 5, 6, they all comes under the natural number, and the set of natural number is denoted as n, capital N. So let us know regarding what is a natural number. So, natural number means counting numbers 1, 2, 3, 4, 5 are all called as natural numbers. They are also called as positive integers, and it is denoted as n is equal to 1, 2, 3, 4, 5 etc. are called as the counting number. So, the set of natural number is denoted as n. N is equal to all counting numbers 1, 2, 3, 4 is called as a natural number. Now, what is meant by a whole number? So, whole number is nothing but all the natural numbers together with 0, including 0. All the natural number including 0 will comes under a set that is called set of whole numbers. So, the set of whole numbers including natural number with 0 is a set of whole numbers. 0 is added to any natural number. Suppose if you add 0 to any natural number, what we will get? The same number we will get. 0 plus n is equal to n, or n plus 0 is also equal to n for all n belongs to n. Let us consider for example 2. 2 plus 0 is equal to 2. This is also equal to 0 plus 2. That is equal to 2 belongs to n. Suppose if 0 is added to any natural number, then number n, then it will give the same number. Right? That is 0 plus n is equal to n plus 0 is equal to n for all n belongs to n. For all n belongs to n. So, for example, 2 plus 0 is equal to 2, that is also equal to 0 plus 2 is equal to 2. Similarly, let us take 3 plus 0 is equal to 3. This is also equal to 0 plus 3, that is equal to 3, belongs to n. So, therefore, the set including with 0, 0, 1, 2, 3, 4, etc. comes under the set that is called the whole number, denoted as W. So, therefore, in total, the set of natural numbers is denoted as n. N contains all the counting numbers like 1, 2, 3, and the set of whole numbers is denoted as W, which includes 0 as well as all 1, 2, 3 natural numbers, positive numbers. So, this is regarding the natural numbers and the whole numbers. Now, let us come to the next concept, integer. Now, let us know regarding an integer. Integer means the set of all positive integers, negative integers together with 0 will form a set that is called as the set of integers, and it is denoted as I or Z. So, usually the set of integer is denoted as I or Z. I or Z is nothing but all the 0 including all positive and negative numbers. So, 0 plus or minus 1 plus or minus 2 plus or minus 3 etc. comes under the set that is called set of integers. So, that is 0 plus 1 plus 2 plus 3 minus 1 minus 2 minus 3 etc. will comes under the set of integers denoted as I or Z. So, the set of all positive integers and negative integers together with 0 will form a set of integers denoted as I or Z, which contains all positive and negative integers, 0 plus or minus 1 plus or minus 2 plus or minus 3 etc. That is 0 plus 1 plus 2 plus 3 etc. minus 1 minus 2 minus 3 etc. will form a set of integers denoted as I or Z. Okay, understood? Now, let us come to the next concept, odd and even number. This is very important concept in this number theory, odd and even number. You might have been studied in your previous classes. What is an odd number? Odd number means the integers like 1, 2, 1, 3, 5, 7. The integers like 1, 3, 5, 7 comes under a set called set of odd integers. That means the numbers which are not divisible by any other number except one and the same number. These, take for example 3. 3 cannot be divisible by any other number except 3 and 1. The numbers which are not divisible by any other number except one and the same number comes under a group that is called as the odd integers, odd numbers. The integers like 0, 2, 4, 6 etc. minus 2, minus 4, minus all positive as well as negative integers like 2 plus or minus 4 plus or minus 6 plus or minus, they are comes under a set called as the even numbers that can be divisible by any other number and the same number. That means they can be expressed as the factor of other numbers. So, therefore, here 1, 2 and 3 are called as positive integers. 1, 2, 3 are called positive integers, whereas minus 1, minus 2, minus 3 are called as negative integers, and 0 is neither a positive or a negative number. So, therefore, we assume that it is never a even or an odd number. So, here 1, 3, 5 are called as odd numbers, whereas minus 2, minus 4, minus 6, plus 2, plus 4, plus 6 and 0 are called as even integers, whereas 0 is neither a positive nor negative. So, just we will assume it as neither an even number and an odd number, neither even nor it is an odd number. Okay. Now, let us come to the very important concept that is called as the prime numbers. Prime numbers. Prime numbers mean an integer p greater than 1. Here this is very important. An integer p which is greater than 1 is said to be a prime number if it has no divisor except one and the same, one and itself. The numbers greater than 1, the numbers p which is greater than 1 is said to be a prime number if it is not divisible by any other number except the same number and 1 is called a prime number. So, a number p is greater than 1 is said to be a prime number if it has no other divisors except one and itself, except one and the same p will forms a prime number. Let us consider for example 2, 3, 5, 7. They are all example for 5 numbers. See, you cannot divide 3 or 5 by any other number except the same number. Let us consider 7. You cannot divide 7 by any other number except 7. Similarly, if you consider 11 and 13, you cannot divide the number 11 by any other number except 1 and 11. So, these are all examples for 5 numbers. That means, numbers which are not divisible by any other number except 1 and the same number. That means, we cannot express it as the factors of any other number except 1 and the same number. So, 13, 17, they are all example for prime numbers. Now, 2 is only the even prime number. Here, 2 is only the even prime number. Remaining are all odd prime numbers. So, the prime numbers are infinite. There are infinite number of prime numbers, right? Now, let us come to, after knowing the prime numbers, the next important concept is the composite number. Composite numbers, prime numbers and composite numbers. Composite number are nothing but an integer which is not a prime number is called a composite number. Example 4, 6, 8, 9, 10, 13, 12, 14, this etc. These are all example for composite numbers. So, that means any number can be expressed as the factor of other numbers. It can be divisible by any other number other than 1 and the same number. So, let us consider for example 9. 9 can be divisible by 1, 3 and 9. So, this 9 can be expressed as 3 into 3. Factors of 9 are 3 into 3, 1 into 3, 1 into 9 and 9 into 1. So, here 14, even 14 can also be divisible by 2, then 7 and 14. So, that means this can be expressed as the factors of other. So, therefore, an integer which is not a prime number is called a composite number. 4, 6, 8, 9, 12, 10, 12, 14, they are all example for composite numbers. So, a composite number n has a divisors other than plus or minus 1 and plus or minus I. So, the composite number will have the divisors other than plus or minus 1 and the plus or minus n. So, that means it can be expressed as the factors of other numbers also. Now, 0 and 1 are neither prime number or composite numbers. 0 are neither prime numbers or composite numbers. 0 as well as 1. 0 and 1 are neither prime numbers or composite numbers, whereas 2 is only the even prime number. See, 2 is only the even prime number, 0 and 1 are neither prime number or composite numbers. Now, these are few concepts of prime numbers as well as the composite numbers. Now, let us come to the very important concept in this chapter is fundamental theorem of arithmetic. The fundamental theorem of arithmetic says, what is a fundamental theorem of arithmetic? Every composite number can be expressed as the product of primes and its decomposition is unique. So, any composite number can be expressed as the product of its prime numbers. Any composite number can be expressed as the product of prime numbers, and this decomposition is unique. This is unique decomposition. So, that means any composite number can be expressed as the product of their prime numbers. Now, let us consider for example the factors of 35. What are the factors of 35? Can be factorized as 5 into 7 or 7 into 5. 5 7s are 35 or 7 5s are 35. So, here let us consider 35. 35 can be written as 35 is equal to 5 into 7 or 7 into 5. These are the factors. That means 35 can be written as 5 into 7 or 7 into 5. So, therefore, the prime factors of 35 is 5 to the power of 1 into 7 to the power of 1. 35 can be written as, let us start with 5 to the power of 1 into 7 to the power of 1. Similarly, let us consider 24. 24 can be written as, so how to write 24? This 24 can be written as 2 into 2 into 2 into 3. That is 2 2s are 4, 4 2s are 8, 8 3s are 24. This is nothing but 2 cube into 3 to the power of 1. So, 24 can be expressed as 2 cube into 3 to the power of 1. So these are called the prime factors of 24. Now the prime factors of 28 are 28 can also be written as 28 can be written as 4 into 7. 4 can be written as 2 square. So 2 square into 7 to the power of 1. 7 fours are 28. So 2 square into 7 to the power of 1 is the prime factor for the number 28. Okay. So this is how we are going to express a composite number as the product of their prime numbers. So this is called the fundamental theorem of arithmetic. So what is the fundamental theorem of arithmetic? The fundamental theorem of arithmetic says any composite number can be expressed as the product of their prime numbers. Product of the prime numbers. That's it. That is, so this is called the prime factorization, or it is also called as this type of representation of a composite number is called as the canonical representation. In the examination they may ask, write the canonical representation of the given number. Okay. So we are going to, this is called the canonical representation of the given number, composite number. Now with the help of this fundamental theorem of arithmetic, that is a canonical representation of a composite number, we can find, with the help of this theorem we can find, or we can apply to find out the number of positive divisors of a number, the number of positive divisors. So the number of positive divisors of a composite number can be determined with the help of this prime factorization theorem, and the sum of all positive divisors can also be determined with the help of this concept. So the sum of all positive divisors of the number as well as the number of divisors. So the number of divisors is nothing but Tn. If n is a number, the number of positive divisors of that is denoted as T of n, and S of n is the sum. So the total number of divisors and the sum of all positive divisors can be determined with the help of this fundamental theorem of arithmetic, that is with the help of a canonical representation of a composite number. Now let us see what is that equal to. Let n is a composite number. We know that any composite number can be expressed as the product of prime numbers. Now that is, let us consider, let the given number n can be expressed as the product of prime numbers, that is p1 to the power of alpha 1 into p comma p2 to the power of alpha 2 comma p3 etc. pn to the power of alpha n, where p1 p2 p3 etc. pn are called the distinct prime numbers, and this T of n will denote the number of positive divisors of n. So the number of positive divisors of n is given by T of n is equal to 1 plus alpha into 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3 etc. 1 plus alpha n. If you multiply the product of 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3 etc. will gives the number of positive divisors of the given number. So where here alpha 1, alpha 2, alpha 3 are the powers, p1, p2, p3 are the bases. The bases p1, p2, p3 are all distinct prime numbers. Now we are going to consider the powers here, 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3 etc. 1 plus alpha n, the product will give the number of positive divisors. So the number of positive divisors of n is denoted as T of n and is given by the number of positive divisors. T of n is equal to 1 plus alpha 1 into 1 plus alpha 2 etc. 1 plus alpha n. That's it. Okay. Now suppose if you want to find the sum of all these positive divisors, then it is denoted as S of n. For this we are going to consider P1 alpha 1, P2 alpha 2. So that is Sn will denote, S of n will denote the sum of all positive divisors of n. Then we have S of n is equal to P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1 etc. Pn to the power of alpha n plus 1 minus 1 divided by Pn minus 1 will gives the sum of all positive divisors of the given number. Okay. Now this is how we are going to find the sum of all positive divisors as well as the number of positive divisors of the given composite number. Now let me take one small example. Now let us consider 24. For example, if 24 is a composite number. Now let us represent this 24 in the canonical form first. So 24 can be factorized. Let us start with 2. 2 ones are 2 twos are again 2 6 are again 2 into 3. So 24 can be written as 2 to the power of 1, 2 and 3, 2 cube into 3 to the power of 1. So this is nothing but P1 to the power of alpha 1 into P2 to the power of alpha. So therefore 24 can be written as 2 cube into 3 to the power of 1. That is nothing but P1 to the power of alpha 1 into P2 to the power of alpha 2. This type of representation is called as the canonical representation. Canonical representation of the given composite number. Now, what is P1 here? Here we have P1 is equal to 2 and P2 is equal to 3. What is alpha 1? Alpha 1 is equal to 2 and alpha 2 is equal to 1. Now, let us find out the number of positive divisors. The first one, the number of positive divisors is denoted as T of n. What is the formula for T of n? 1 plus alpha 1 into 1 plus alpha 2. So, T of n is equal to 1 plus alpha n into 1 plus alpha 2. So, the number of positive divisors of n, what is n here? N is nothing but the given number. T of 24 is equal to 1 plus, what is alpha 1? Alpha 1 is 2 into 1 plus, what is alpha 2? Alpha 2 is 1. So, 1 plus 2 is 3, 1 plus 1 is 2, 3 plus 2 is 6. So, the number of positive divisors are 6. 6 positive divisors are there for this 24. So, therefore, the number of positive divisors for 24 is 6 are the number of positive divisors. Now, how to find the sum of positive divisors? The sum of positive divisors is denoted as Sn. Sn is equal to, what is the formula? P1 to the power of alpha 1 plus 1 divided by minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1. Now, substitute the values. What are the values here? P1. P1 is nothing but 2 to the power of alpha 2. Alpha 2 is 2 plus 1. 2 plus 1 is 3. 2 cube minus 1 divided by P1 minus 1. P1 is 2 minus 1. 2 minus 1 into P2. What is P2? P2 is 3 to the power of alpha 2. Alpha 2 is 3 to the power of alpha 2 is 1 plus 1 is 2 minus 1 divided by P2. Again P2 is equal to 3 minus 1. Simplify this. If you simplify, what you are going to get? 2 cube. 2 cube is 2 to the 4 to the 8 minus 1 is 7 divided by 2 minus 1 is 1 into 3 square. 3 square is 9. 9 minus 1 is 8 divided by 3 minus 1 is 2. So, this is nothing but 4 2s are gets cancelled. 7 into 4. 7 4s are 28. That's it. So, the sum of positive divisors is equal to 28 and the number of positive divisors are 6. This is how we are going to simplify. We can find the number of positive divisors and sum of positive divisors for a given composite number. Hope you followed. That's it. This is the very simple concept. These are very simple concepts which you are going to study in this chapter. That's it. Now, let us take problems based on this. Now, let us come to the first problem. Find the number of positive divisors and the sum of positive divisors of the following number. So, what is the number given? 60. Now, let us represent this 60 in the canonical form first. Now, 60. Let us start with 2. 2 into 30. Again 2 into 15. 15 you cannot divide by 2. Let us go to the next number. 3. 3 5s are 15. So, 5 1s are 5. So, this 60 can be written as 60 is equal to 2 to the power of 1 into 2. 2 square into 3 to the power of 1 into 5 to the power of 1. So, this is called the canonical form of 60. Now, this is of the form P1 to the power of alpha 1 into P2 to the power of alpha 2 into P3 to the power of alpha 3. Now, what is alpha 1? Alpha 1 is 2, alpha 2 is equal to 1, alpha 3 is also equal to 1, whereas P1 is equal to 2, P2 is equal to 3 and P3 is equal to 5. See here, alpha 1, alpha 2, alpha 3 are 2, 1, 1 and P1, P2, P3 are 2, 3 and 5. Now, let us find out the first one. What is the first one? First one is nothing but the number of positive divisors. Number of positive divisors are T of n. T of n is equal to 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3. Now, what is the formula? 1 plus T of n is 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3. So, T of n, what is n? 60 is equal to 1 plus alpha 1 is 2 into 1 plus alpha 2 is 1, 1 plus alpha 3 is 1. 3 into 2 into 2. 3 2s are 6, 6 2s are 12. So therefore, the number of positive divisors of 60 are 12. 12 positive divisors you are going to get. Okay. Now, let us come to the sum of positive divisors. The sum of positive divisor, sum S of 60 is equal to, what is the formula? P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1 into P3 to the power of alpha 3 plus 1 minus 1 divided by P3 minus 1. Okay, this is the formula. Now, so this here, what are the values we have? P1, P2, P3, alpha 1, alpha 2, alpha 3. So, what is P1? P1, P2, P3 are 2, 3, 5. 2, 3 and 5. Alpha 1, alpha 2, 2, 1, 1. 2, 1, 1. Right. 2, 3, 5. Let me check. 2, 3, 5. 2, 3, 5. 2, 1, 1. 2, 1, 1. Now, this is the formula. Write down. S of 60. P1. P1 is 2 to the power of alpha 1 plus 1. 2 plus 1 is 3 minus 1 divided by P1 is 2 minus 1 into P2. What is P2? 3 to the power of alpha 2. Alpha 2 is 1 plus 1 is 2 minus 1 divided by P2 is 3 minus 1 into P3. P3 is 5 to the power of alpha 3 is 1 plus 1 minus 1 divided by 5 minus 1. So, this is 2 cube. 2 cube is 8 minus 1 divided by 2 minus 1 is 1 into 3 square. 3 square is 9 minus 1 divided by 2 into 5 to the power of 2. 5 square. 5 square minus 1 by 4. 5 square is nothing but 25 minus 1. 25 minus 1 divided by 4. So, this is equal to 8 minus 1 is 7. 9 minus 1 is 8 divided by 2. 25 minus 1 is 24 divided by 4. So, 4 2s are 8 gets cancelled. What is remaining is 7 into 24. Write down the value of 24 7s are, that's it. So, 24 into 7 is 168. 168. So, therefore, the sum of all positive divisors of 60 are S of 60 is equal to 168. So, the number of positive divisors of 60. What are the number of positive divisors? 12. 12 positive divisors, whereas the sum of positive divisors are 168. This is how we are going to simplify. This is very important question for 3 marks, right? Hope you followed. Okay. Now, let us take a similar type problem. Now, let us take the next problem. Now, what is the problem? Find the number of positive divisors and sum of positive divisors of the following number. What is the number given? 360. Let us factorize 360 and express it into the canonical form first. So, 360. Let us factorize this. Take divide by 2. 2 18s, 18 2s are 36. 180 into 2 is 360. Again from 2, 9 2s are. Again from 2. So, it can be divisible by 45 times. Okay. Now, again start with the 3. 3, 3, 15s are 15 3s are 45. Again 3 5s are 15. So, this can be written as, so 360 can be written as 2 to the power of 1, 2 and 3, 2 cube into 3 to the power of 2, 3 square into 5 to the power of 1. This is the canonical representation of 360. Now, this is of the form, if you observe carefully, this is of the form P1 to the power of alpha 1 into P2 to the power of alpha 2 into P3 to the power of alpha 3. What is P1 here? P1 is 2, P2 is equal to 3 and P3 is equal to 5. Similarly, what are the values of alpha 1? Alpha 1 is equal to 3, alpha 2 is equal to 2, alpha 3 is equal to 1. Now, let us find out the first one. What is the first one? Number of positive divisors, T of n. That is nothing but T of n is equal to 1 plus alpha 1 into 1 plus alpha 2, etc. That is T of 360 is equal to 1 plus, what is alpha 1? Alpha 1 is 3 into 1 plus alpha 2 is 2 into 1 plus alpha 3 is 1. So, this is 3 plus 1 is 4 into 3 plus 2 plus 1 is 3 into 1 plus 1 is 2. So, 4 3s are 12, 12 2s are 24. So, the sum of the number of positive divisors for 360 is 24. Now, let us come to the next concept, that is sum of these positive divisors. Now, what is the formula for sum of positive divisors? Now, to find the second concept, sum of all positive divisors, to find the sum of all positive divisors, S of n is equal to, what is the formula? P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1 into, next term is P3 to the power of alpha 3 plus 1 minus 1 divided by P3 minus 1. Now, what are the values here? Let us write P1, P1, P2 and P3. What are the values of P1, P2 and P3? 2, 3 and 5. 2, 3 and 5. What are alpha 1, alpha 2, alpha 3? Alpha 1, alpha 2, alpha 3 are 3, 2, 1. Now, let us substitute here. S of 360 is equal to P1, 2 to the power of alpha 1. Alpha 1 is 3 plus 1 minus 1 divided by P1 is 2 minus 1 into P2. What is P2? 3 to the power of alpha 2. Alpha 2 is 2 plus 1 minus 1 divided by P2. P2 is equal to 3 minus 1 into P3. P3 is nothing but 5 to the power of alpha 3. What is alpha 3? Alpha 3, this is alpha 3 is equal to, yes, 1. 1 plus 1 minus 1 divided by P3 is nothing but 5 minus 1. Simplify this, that's all. 2 to the power of 3 plus 1 is 4 minus 1 by 1 into 3 to the power of 2 plus 1 is 3. 3 cube minus 1 by 2 into 5 to the power of 1 plus 1 is 2. 5 square divided by 5 minus 1 is 4. 5 square minus 1. Now, what is this equal to? 2 to the power of 4. 2 to the 4, 4 to the 8 to the 16. 16 minus 1 is 15 into 3 cube. 3 3s are 9, 9 3s are 27. 27 minus 1 is 26 divided by 2 into 5 square. 5 square is 25 minus 1 is 24 divided by 4. Simplify this. So, this is equal to 15 into, so 6 4s are 24, 6 times it will get cancelled, 13 2s are 36, 15 into 13 into, this is 6. 15 into 13 into 6 will give the value, that's it. So, if you simplify, you will get 1170, that's it. Okay. So, 2 to the power of 4, 2 raised to 4 is 2 to the 4, 4 to the 8 to the 16, 16 minus 1 is 15, 3 cube, 3 3s are 9, 9 3s are 27 minus 1 is 26 divided by 2 and 5 square is 25 minus 1 is 24 by 4. So, 13 2s are 26, again if you divide 24 by 4, 6 4s are 24, 15 into 13 into 6 will give the value as 1170, that's it. This is how we are going to find out the number of divisors and sum of positive divisor for this given number. Now, let us come to the next problem, similar type problem. Let us take this problem, very easiest and important problem. Find the number of positive divisor and the sum of positive divisors for 1024, 1024. You know the value of 1024 can be written as 2 to the power of, let me check how much we will get. So, 2 to the power of, this is 5, then 1 and 2, 512. Again, if you divide by 2, how much you will get? Half of 512 is 2. 2 2s are 4, 2 5s are 10, 2 6s are 12, 256. Again, if you divide, 2 1s are 2 2s are 4, 2 8s are 16, 128. Again, if you divide by 2, 2 6s are 2 4s are 64. Again, if you divide by 2, 2 3s are 2 2s are again by 2, 2 16s are 16 2s are. Again, if you divide by 2, 2 8s are 16. Again, this 8 can be written as 2 4s are, again 4 can be written as 2 2s are. So how much, what is the value we are going to write? 2 into 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you know 2 to the power of 24, sorry, 10 to the 10 24 is always equal to 2 to the power of 10. So 2 to the power of 10 is the value of 1024. So this is the standard result, you know. Straight away you can write 1024 as 2 to the power of 10. Now this can be written as 2 to the power of 10 is nothing but P1 to the power of alpha 1. Right. So here P1 is equal to 2 and alpha 1 is equal to 10. So that sum of positive, total number of positive divisors, T of n is equal to 1 plus alpha 1. So that is nothing but 1 plus alpha 1. Alpha 1 is 10. So 11 divisors are there. So the number of positive divisors of 1024 is 11. Okay. Now come to the sum of positive divisors. Now what is the formula for sum of positive divisor? S of 1024 is equal to P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1. P1 minus 1. So what is P1 here? We have P1 and alpha 1. P1 as 2 and alpha 1 as 10. Substitute here. P1 2 to the power of alpha 1 is 10 plus 1 minus 1 divided by 2 minus 1. 2 to the power of 11 minus 1 divided by 2 minus 1 is 1. So 2 to the power of 11 minus 1. Now, what is the value of 2 to the power of 11? Since you know the value of 2 to the power of 10, 2 power 10 is 1024. 2 to the power of 11 can be written as 2 to the power of 10 into 2 to the power of 1. What is 2 to the power of n? 1024 into 2. So 1024 into 2, if you multiply by 2, 2 4s are 8, 2 2s are 4, 0, 2 1s are 2, 2048. So this is equal to 2048 minus 1 is 2047. So therefore, the sum of all positive divisors of 1024 is 2047, 2047. Okay, very simple and important for 3 months, right? Now let us take last problem in this. So find the number of positive divisors and sum of positive divisors of 960. Now let us factorize this 960 first. 960 can be written as from 2. 2 4s are, 2 8s are, 0. Again 2 2s are, 2 4s are and 0. Again from 2. 2 1s are, 2 2s are and 0. Again 2 into 60 is 120. Again 2 into 30. Again 15 can be written as, so you 2, if you divide from 2, 2 1s are, 2 5s are. Again this is nothing but 3 into 5. So therefore 1, 2, 3, 4, 5, 6. So this can be written as 960 can be written as 2 to the power of 6 into 3 to the power of 1 into 5 to the power of 1. So 960 is equal to 2 power 6, 3 power 1 into 5 to the power of 1. This can be written as P1 to the power of alpha 1 into P2 to the power of alpha 2 into P3 to the power of alpha 3. This is called the canonical representation of the given number. Now what is P1 here? P1 is equal to 2, P2 is equal to 3 and P3 is equal to 5. Similarly, alpha 1 is 6, alpha 2 is equal to 1, alpha 3 is also equal to 1. Now find out the first one, number of positive divisors. Number of positive divisor is nothing but T of n is equal to 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3. So T of n is nothing but 960. 1 plus what is alpha 1? 6 into 1 plus what is alpha 2? 1. Alpha 3 is also 1. 1 plus 1. 7 into 2 into 2. 7 2s are 14. 14 into 2. That's equal to 28. So therefore, the number of positive divisors of 960 is 28 positive divisors are there. T of 960 is 28. Okay. Let us come to the sum of positive divisors. So I will write here. What is the formula for S of n? S of n is equal to P1 to the power of alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 to the power of alpha 2 plus 1 minus 1 divided by P2 minus 1 into P3 to the power of alpha 3 plus 1 minus 1 divided by P3 minus 1. Okay. Now write down the values of P1, P1, P2, P3 and similarly alpha 1, alpha 2 and alpha 3. What is P1, 2, 3, 5? 2, 3 and 5. Alpha 1, 6, alpha 2, alpha 3 are 1 and 1. Now simplifier. So S of 960 can be written as P1, 2 to the power of 6 plus 1, 6 plus 1 minus 1 divided by 2 minus 1 into P2. P2 is 3, 3 to the power of alpha 2 is 1 plus 1 minus 1 divided by 3 minus 1 into P3, 5 to the power of alpha 3. Alpha 3 is 1 plus 1 minus 1 divided by 5 minus 1. Right. So this is 2 power 6 plus 1 is 7 minus 1 by 2 minus 1 is 1. 3 to the power of 1 plus 1 is 2 minus 1 divided by 2. 5 to the power of 2 minus 1 divided by 4. So this is 2 power 7. 2 power 7 means just multiply 7 times. 2 2s are 4. 2 to the power of 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2 2s are 4. 4 2s are 8. 8 2s are 16. 16 2s are 32. 32 into 2 is 64. 64 into 2 is 128. So this is 128. So 128 minus 1 into 3 square. 3 square is 9 minus 1. 9 minus 1 is 8 by 2. 5 square. 5 square is 25 minus 1 is 24 divided by 4. Now what happens? So this is 4 2s are 8 gets cancelled. 128 minus 1 is 127 into 1 into 24. 127 into 24. 127 into 24. This is equal to 3048. 3048. So the sum of positive divisor of 960 is 3048. That's it. So that's regarding this sum of positive divisors and number of positive divisors of 960. Okay. So hope you followed how to find the sum of positive divisors and the number of positive divisors. So the number of positive divisors are T of n and the sum of positive divisors are S of n. This is very important concept. So that's all regarding today's session. Let us meet with different type of problems in the next session. Thank you very much.